Okay, thank you. Okay, so hi everyone. So in this presentation, I'll be talking about how the O2 IMS can be achieved with the Nephio architecture. And yeah, so this content is prepared by Alexis and me, but I'll be presenting alone as he could not join today. So I'll start with a brief introduction about how the overall RAN architecture is getting involved, and at what stage in the evolution of RAN will we be able to adopt a platform like Nephio for the orchestration and management of both the infrastructure as well as the workload. And the evolution of the RAN is basically being managed by very well-known visible organizations like 3GPP or RAN Alliance and TIP. So how the RAN architecture is evolving? So RAN architecture is basically driven towards uh, a disaggregated and virtualized architecture, which will be able to run on open hardware and cloud. So 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 there is so when I talk about disaggregated architecture, there are specific components which are getting defined. The GNB to be specific, the CUDU and the RAN unit. The specification basically defines the standardized interface for intercommunication between these components, and that basically enables the SMO to basically interface over standardized APIs for the deployment of these network functions and the configuration of these network functions. Now, along with that, even the platform which will host these network functions or which will enable the deployment and management of these network functions, so that is also getting standardized, and that is referred to as open cloud here, and which basically exposes an O2 interface. So now, via the O2 interface, which is going to be a standard interface, the SMO will be able to provision and manage the infrastructure, and then also deploy the workloads, which are these network functions via the O2 interface. So this talk is more about the O2 interface, and we will see how the Nephio's current architecture uh, basically can be adopted here to implement the O cloud. So O2 RAN IMS, the standard profile or the standard Kubernetes API is getting defined, which is in line with the O cloud DMS. And what basically brings in with the declarative model or declarative design for the infrastructure management. So with the declarative API, declarative infrastructure management layer, what we can leverage is the Kubernetes ecosystem, which is rapidly evolving. And also, once we declare the cloud native Kubernetes APIs for the provisioning and management of the infrastructure as well, we can basically facilitate the adoption of the cloud native orchestrator like Nephio, and that is what the talk is about. So this is how basically the overall architecture of RAN is getting driven, and the evolution is happening towards a more cloud native way of performing things. And platforms like Nephio are they will basically become a perfect fit for the automation and orchestration in the RAN world. And when it comes to the infrastructure management, there is already a lot of work that has happened there. There are Kubernetes operators and Kubernetes APIs for example, for the metal discovery, metal provisioning via the metal cube kind of projects. And then also the cloud vendor also has created Kubernetes APIs. For example, ACK from AWS, using these Kubernetes APIs, you can, via the declarative APIs, you can create and manage infrastructures. EKS is an example. So the IMS, when it becomes a Kubernetes API, or to say a custom resource, a controller, can basically leverage these already existing controllers or CRDs for performing the infrastructure provisioning. That can basically start right from your metal provisioning for the on-prem use cases, or metal provisioning from a metal provider, metal service provider like Equinix, or it could be a managed Kubernetes cluster on a platform like AWS. So on top of everything, a standard interface which is being defined by the ORAN will basically, yeah. So that is the overall motive. The standard interface, it becomes free for deployment on an open cloud or open hardware. So with that introduction, now I will talk about how the Nephio's current architecture can be utilized or can be adopted for the ORAN O2 IMS as well as DMS. So IMS is for infrastructure and DMS is for the deployment of the workload. So Nephio, I mean, there have been, I mean, previous sessions, people have already seen what Nephio is, and so I will not spend much time on explaining what Nephio is. So just a brief introduction. So Nephio is an intent-driven, declarative cloud native platform for the orchestration and management of all three verticals, which are basically the infrastructure, and on that infrastructure, the workload, followed by the lifecycle management of these workloads. So on this slide, what we see is the Nephio, the current architecture of Nephio, which we will see in R1. So it is meant for workload orchestration as of today, but the same design principles, I mean, using the same design principles, how we can basically use the Nephio as OCloud and the underneath the IMS and DMS. So top layer is I've put it as SMO, and SMO has FOCOM and NFO. So FOCOM basically is supposed to call the IMS related standard APIs for the management of infrastructure, which can begin right from provisioning of Kubernetes cluster, provisioning of infrastructure, and then I mean the bookkeeping kind of work, querying the inventory and management, etc. So FOCOM API. So Nephio basically exposes. So in Nephio, for the automation automation of either it is workload infrastructure or day and configuration, the user is supposed to provide high level intent, and that high level intent basically is reconciled by the Nephio intent controllers. So in this case, what we are saying is the FOCOM basically specifies an IMS intent, which could be a request to create a Kubernetes cluster on either on-prem, or it could be on the cloud provider's managed Kubernetes cluster. So the way Nephio works is that we have to define the base packages. These base packages basically define the configurations for workloads, configurations for infrastructure. So as an example, I could create a KPT package, which basically defines an EKS cluster, or which defines which defines the cluster API Kubernetes cluster API Kubernetes objects for creating a kind cluster as an example. So base package, let's take EKS as an example, and there is a base package that is present, which contains all the Kubernetes, all the definition for all the Kubernetes resources that we need in order to spin an EKS cluster. And then as from the FOCOM, I specify an intent that I need an EKS cluster in a specific region with this specific configuration. So my intent controller will basically reconcile to this intent that the FOCOM specified. So intent controller can pull the base package from a repo. We can call this the infrastructure repo via a Git controller. And then this intent controller will basically take the base package and it will enhance it, curate it as per the intent that is specified. So for example, base package it will not contain any information about like which region, in which region I want to spin an EKS cluster. So based on the intent, it could basically enhance this package and fill in the information about regions, etc. And this is an example. An intent controller can get different sorts of information filled into the base package, and that it does with the help of other controllers, which are called the intent specializers. And yeah, so basically the control will run through different specializers, and we get a curated package which has all the information that is required for the Kubernetes in order to spin an EKS cluster with the configuration that the user specified, or in this case, the FOCOM specified in the high level intent. And then that specialized package is pushed to another repo. And this repo is basically linked to our O Cloud cluster. And I will come to why I call this as a workload cluster also, to this O Cloud. Yeah, so this O Cloud repo is basically configured with this O Cloud cluster, and there is reconciliation engine that is running, which is basically continuously reconciling the packages which are pushed into this O Cloud repo. So at this point, this will see that there is a new package, which is pushed here, and it will just reconcile it. And as part of the reconciliation, it will end up creating an EKS cluster. Now, I took an example of EKS here, but now with the IMS, which is basically trying to standardize this Kubernetes interface, this KPT package can contain that CRD as the base, and then that CRD will be enhanced and curated by the intent controllers above, and then this infra controller, which I call as IMS, this will reconcile the this IMS intent, and yeah, as part of reconciliation, it will end up creating all the Kubernetes resources, which is Kubernetes cluster in this case, in the specified region. And as I said, in the northbound, it will expose a standard interface, but southbound, it could call the AWS ACK. It could trigger the AWS ACK custom resources that basically are already present today, and they will create the Kubernetes cluster. Or it could also create the custom resources of Metal Cube, for example, and Metal Cube will perform the discovery of the Metal discovery and the provisioning of a Metal server. Followed by that, we can use cluster API in the southbound for the provisioning of Kubernetes on top of that. So there are a lot of, possibilities, a lot of ways in which we can achieve this. But overall, this flow basically shows how even the current, the Nephio, which will be released in R1, can be imagined as O Cloud provider. Now this O Cloud also is a Kubernetes cluster, right? And somebody, I mean, if we follow the spec, then the first step itself is to bootstrap this OCloud and then uh, basically registering this OCloud with the SMO. If I consider this as one of the workload clusters, so the bootstrap of this cluster itself can happen in a very similar manner. In that case, the controllers which basically create the Kubernetes controllers which create the infrastructure can sit in the Nephio management cluster, and they will end up creating this OCloud Kubernetes cluster, followed by the deployment of these specific controllers, which is the standard specific IMS controller, standard specific DMS controller, and the reconciliation engine. So that is how the life cycle can be uh, using the Nephio architecture. So this is about infrastructure. Now the next part is the infrastructure that is created. I want to install a CUDU container on these. So using using the same design principles, the how we can do it in the Nephio way, it is very similar. So here I am.
Sandeep,
So
sorry
previous,
to interrupt. Are we taking the questions at the end, or it's like I do have some comments and would like to check on the IMS side of things before we jump to the DMS parts? Yeah, I think. Yeah. Okay. Yeah. Thank you. I mean, if I try, I'm part of the ORAN WG6 involvement, and I'm one of the contributors in that work group, which deals with and specify the O2 architecture and the specifications around the O2. So, I mean, there we follow like a two-tier architecture, right? The SMO has the interface with the IMS over the O2 IMS interface.
Yeah.
And what I can see in this flow is more of a three-tier architecture, right? The SMO, and then comes the Nephio management cluster layer, and then afterwards we have the infra controller, which you are calling like an IMS. Yeah. So the interface between FOCOM and the IMS, which is the O2 IMS interface, O2M interface in ORAN.
Yeah.
Is it like the whole workflow engine that you are showing here, which includes Git controller, intent controller, specializers, all the repos and the reconciliation engine running inside the OCloud cluster? So how
the
it is?
components that I put in the Nephio management cluster. So this is what Nephio comprises of, and I have put generic names here: Git controller, intent controller. But next slide shows what will be there in R1. So this is already, let's assume that this is already existing Nephio architecture. So now on top of this, I am basically fitting the interface, which is IMS, which is an interface towards the FOCOM. And I do agree that so these interfaces are like, I mean, there are specific APIs which are getting defined, which FOCOM is supposed to call at the IMS layer, right? So if we have to fit it like this arrow from FOCOM to intent controller, it might not be a straight arrow. There could be a shim layer between this, which will basically serve the APIs which are standard specific, the IMS infrastructure APIs. And in the southbound, it will create these custom resources with the high level intents at the for the Nephio. So that basically will complete the picture. So for this question, I had created a backup slide. So this is how it could be. I mean, so O2 IMS I showed as this green box. Let's imagine that it is Nephio altogether. And from FOCOM, so there is this layer, this extra layer that I have put, OCloud interface. So FOCOM basically this OCloud interface will expose the standardized IMS APIs. But southbound, it will just create Nephio high-level intent CRs. So in that way, basically, yeah, this gets plugged in.
So it's more of an adapter that, or a shim layer, like as you called.
It could be required, yeah.
Yeah.
Yeah,
so,
but yeah, but what the standards is defining is more of at this layer, the IMS, that CRD, right? For
Right.
yeah.
So in between FERCOM and IMS, I see more of like this is all implement one specific realization of what we are defining in, let's say, in ORAN specifications, right? So which comprises all these different controllers plus the repos and the reconciliation engine, and that becomes our one way of realizing the O2 IMS interface, right?
Exactly. This becomes one of the ways we can achieve this. And whatever is there, so this is Nephio. I mean, management controller, they are there already. I mean, as of today, it is not targeted that much for infrastructure, but that will come.
Yes.
But it will be enhanced with the same design principles. So, yeah.
Yeah. Another comment on the same diagram, you're showing the workload controller as DMS, and if you see the Kubernetes profile for DMS, that's nothing but our Kubernetes workload cluster, right? Which you are basically creating in this purple box, calling it.
Yeah. So,
right?
I mean, by workload controller as exactly, DMS is almost standard Kubernetes API.
Exactly. I mean, it's an endpoint for my workload cluster, right? So where my applications or the network functions will get deployed. So I see no difference between the workload controller parenthesis DMS and the purple box down below, which is Kubernetes cluster, cloud infrastructure, or on-prem bare metal DMS. So I mean, I see a bit overlap between these two boxes. Yeah.
No, I do agree that it is. I mean, it is all Kubernetes API. Yeah, that is correct. But by, maybe I should have put it the other way. By workload controller, I mean specific controllers which will be required for the deployment of CUDU, these network functions, right? So they will sit at the DMS layer. So they will expose Kubernetes API, but it will be specific for CUDU. I mean RAN component deployment. So these controllers will understand the RAN topology. So that is what I intended to put here.
Okay.
Are you referring to Rick here, Sandeep?
No, I'm not referring to. No, there is no real time. There is no
real time. No, when you say workflow CUDU controllers, right? Then it goes in different stream of it.
No, CUDU controller. I mean, if you have to install a CUDU, if you have to install a container, CU container or a DU container, so you will need a Kubernetes controller.
No, I agree. Maybe we can. You're trying to say it's a CNF controller, right? I mean, I understand, but the moment you say CUDU in ORAN spec, it goes into different. I mean, it goes to Vario or Suyo and all. So it becomes again.
CUDU is container. So Rick is altogether a different.
Yeah. Rick is a management layer for those things. I was saying when you say controller for that, right? Then it goes in different. I mean, then the other pieces of the puzzle of ORAN will come into picture. Like here, you're showing the SMO and the OCloud, but then the other piece of the non-real-time Rick kind of those things also will come in the moment you talk about controller.
So if I give you, I mean, let's not get confused with that. It's as simple as a controller which understands how to install
CNF load. Basically, you're talking of NFO extension. In a way, you're talking of NFO extension, right?
Yeah. So there was one more hand actually before you session.
It was Byung. Yeah, it was Byung.
I have a question though. So as Alok said, you have usually SMO and OCloud 2-tier, but now you're introducing one more tier here, 3-tier. So I'm still curious about, because infra controller is triggered by reconcile engine. There's no direct command-based API like O2 IMS. So O2 IMS sitting in between FARCOM and the intent controller. I don't know what's the O2 DMS.
It's same question. So between FARCOM and the intent controller, there could be this is how, So between FARCOM and this OCloud is, let's say this is Nephio, OCloud IMS. So between FARCOM and OCloud, there is this SIM layer, which is OCloud interface. So this layer understands all the standardized APIs of IMS, and in the southbound, it knows how to create the intent. So that is how the flow basically goes into the Nephio and from the reconciliation part.
One follow-up question is OCloud IMS You say this is Nephio management cluster, right?
Driven through Nephio management cluster, yes. So
Yeah, that means you're putting the Nephio management cluster inside the cloud, not separately. Okay,
yeah,
the previous slide, looks like separately, okay.
No, I created it separate because I wanted to show that even this cluster, which is hosting all the OCloud related controllers, will also be, I mean, we have to do automation for this as well, right? But yeah, I mean, I get your point. This whole, from this Nephio management to this purple box, this whole thing is OCloud.
Okay, yeah, I got it. One is
Yeah.
for management cluster, one is workload cluster. Okay, got it. Then. Okay, thank you.
So, okay, one more clarification on this diagram. So the Nephio management cluster layer, which we were showing in the previous chart. So if I follow you correctly, that becomes part of the OCloud and realize the O2 IMS interface, all the controllers that you were drawing, and then until the IMS controller itself, right?
Yeah. So I mean, if I look at it this way, that I have SMO and NFO or FOCOM, which knows how to call standards API. So underneath, it does not know. It could be Nephio. And yes, since the high level intent, which is created by that shim layer, is reconciled by this package variant controller. So this whole thing logically is OCloud for this SMO.
That's inside OCloud. Yeah,
Maybe,
now that
just
makes
a suggestion to just to avoid confusion. Maybe we can have just a one bubble something on all these controllers and show it like, okay, this is the O2 IMS and O2 DMS, and that's one of the realization. So I
got it. Before uploading these slides to my to that page, I will put this as the clarification, the comment.
Perfect. Yeah. Thank you.
But that is the intention. Yeah.
Thank you.
Thanks. So yeah, NFO is no different than the FOCOM, and then this last slide is. It does not talk about IMS, DMS, but this is now it comes to the O1 interface. So it's a very high level idea at present. Even the O1 interface can be achieved by the Nephio-like architecture, provided that we have the controllers which understand the high level O1 intent and convert it to CRs, which are reconciled by the netconf-like controllers. And since the standardized interface for configuration is netconf, and I mean that's how the configuration can happen, and configuration at day 0, day n, all via this Kubernetes controller. And yeah, I mean, not much on this slide. So that's all. That's all I had. So it was basically this this slide, Nephio way of doing the achieving the IMS and DMS.
Thank you. It was great.
Okay.
Thank you.
Thanks, Sandeep.
Thanks.